everybody. Today we are going to be covering lesson 4.4. These notes are available on OMHS if you'd like to follow along with me. Okay. So if you know the sine, cosine, or tangent ratio of an angle, then you can use the inverse function of those things to find the measure of an angle. So what I'd like to do is just show you an example where we have a trig function, maybe the sine of 27. There's this inverse function called sine inverse. That's how we say this. We've heard about inverses before. Examples of some inverses we've seen before, maybe the square root and a square, those cancel each other out. Or adding and then subtracting will cancel each other out. Or multiplying and then dividing. These are all considered inverses because they cancel each other out. One undoes the other. So to undo a sine, we use its inverse called sine inverse. So what I can do is I can show you how an inverse will cancel it out. I'm going to go to Desmos, and I'm going to do this sine inverse. So the sine inverse is kind of hidden here, not really, but if you go click on function here, all of our trig functions are there. Sine inverse is here. So I click sine inverse and then sine, and I'll pick any number you want that's less than 90. Any number at all. I had picked 27. As long as it's less than 90, it will work. Notice what happened. My sine inverse and my sine essentially canceled each other out and left me with just the angle that I typed. This would work for cosine inverse. So the cosine inverse of the cosine. Pick a number less than 90. There it is. And it works for tangent. The tangent inverse of the tangent. Pick any number less than 90. 12. See how they are canceling each other out and giving me just the number that was inside parentheses. So if I need to cancel out one of my trig functions, the way I'll do that is by using its inverse. Okay, so the sine inverse of the sine of 27 is 27. The cosine inverse of the cosine of 42 will be 42. I can do this all day. The tangent inverse of the tangent of a smiley face is equal to smiley face. Okay, these will cancel each other out every time, leaving you with just what the angle was. So let's practice doing that here. Again, it's very important that your calculator is in degree mode. If you had to reset it for any reason, make sure that you are in degree mode. A lot of my students in brick and mortar would have to reset theirs when they went to physics or some science classes. So just be very careful. If you had to do that at any point, make sure you put yourself back into degree mode. Okay. The process, though, is going to be the same process that we were doing last class. Okay, we're still using SOHCAHTOA. We're still putting an arc on the angle. This time it's just X. And we're going to label the sides that are given either O, H, or A. So 24, here's my hypotenuse. 15 is opposite. So I would want to know, well, O and H. That means we're using sine. So this will say the sine of my angle equals the opposite over the hypotenuse. Now here's where it's different from last class. My variable is the angle. I need to get rid of my sine. Remember, to get rid of one of these functions, we have to use the inverse. So I'm going to do the sine inverse of the sine of X. If I take the sine inverse of the left side, then I have to do the exact same thing on the right side. So what I've done is I've just taken the sine inverse of the left side and the sine inverse of the right side. Remember that golden rule of algebra that says whatever you do to one side, you have to do to the other. And now what I can do is cancel out my sines. So now I have X equals the sine inverse of 15 over 24. And that's what I'll type in my calculator, again, in degree mode. So sine inverse 15 divided by 24. 38.7. So x is about 38.7 degrees. Now there's a little shortcut to this. If you understand what I did in this second green step, there's a way to kind of do a little shortcut around that. I'll show you here. Let's look at example 2. My angle is x, the hypotenuse is 11, 8 is the adjacent. So I'm looking at cosine. So the cosine of x equals 8 over 11. What I can do is I can take, okay, here's my angle, here's my ratio. I'm going to flip-flop them. So I'm going to take my ratio and put it in the parentheses, and my angle and put it here. And when I do that, I inverted those, so I make this an inverse. So if I flip-flop my ratio and my angle, then I know that I have to use an inverse. So I can say cosine inverse of 8 over 11. And get my answer 43.3. If you don't like that flip-flop method, you don't have to use it. You can still do the step where you do the cosine inverse of both sides. Oops, oh, X. Whatever way works best for you. I'm going to do one more example here for you. So we'll do our arc on our angle, label the 20 and the 37. 20 is opposite, 37 is adjacent. So I'm using tangent. Opposite and adjacent is with my TOA, or tangent. So the tangent of the angle equals the opposite over the adjacent. I like the flip-flop method, so I'm going to show that. I know I'm going to flip-flop my ratio and my angle. So the angle will come out here, the ratio will go in here, and when I do that, I make this an inverse. So now I can type tangent inverse 20 over 37 in my calculator, and I get 28.4. Try number 4. Put an arc on your angle, label your 18 and 23, decide if you're using sine, cosine, or tangent, and then use your inverse to find the measure of angle x. Do that now. Okay, so you should get x is about 38.5. We used cosine because 18 was adjacent and 23 is hypotenuse. I want to solve for an angle, which means I'm going to have to use an inverse. So I flip-flop my ratio and my angle. When I do that, I make cosine inverse. I type cosine inverse of 18 over 23 in my calculator, and I get 38.5. Okay, so the next page here, we have to practice whether or not we're going to use inverse or non-inverse. Okay, so how do you know when to use an inverse and when to just use the regular function? You'll use the regular function when you're looking for a side. You'll use the inverse of the function when you're looking for an angle. Okay, so in example 7, x is a side, which means I don't need the inverse here. We're going to do exactly what we did last class. We're going to use SOHCAHTOA. And we're going to solve for x. Put an arc on your angle. Label the 11 and the x. 11 is opposite. Opposite. Oh, that's no. x is adjacent. So I'm looking at tangent, O and A. So the tangent of the angle equals the opposite over adjacent. Here's one of those ones where x is in the denominator. Cross multiplying will still work. 11 times 1 is 11. X times the tangent of 39 is x tangent 39. Right, I need to get x by itself. So we're going to divide both sides by the tangent of 39. That'll make my tangent 39's cancel out here. So x equals 11 divided by the tangent of 39. So in our calculator, we will type 11 divided by the tangent of 39. It's about 13.6. So if x is in your denominator, you're going to have to do a little bit of dividing in that second step, which is fine. I'm going to skip down here to number 11. Number 11, x is an angle. So because my missing piece of information is an angle, I know I'm going to have to use an inverse. The angle is x, the hypotenuse is 22, and 14 is an adjacent. So the a and the h goes with cosine. So the cosine of x equals the adjacent over the hypotenuse. I know I'm going to have to use an inverse because I have a missing angle. So I'm going to flip-flop my ratio and my angle. Put the angle out here and the ratio in the parentheses. And when I invert those, I'm using an inverse. So in my calculator, I will type cosine inverse of 14 over 22. That is 50.5. I would like you to try number 8 and number 12. Try those now. Okay, so for number 8, x was a missing side. It was the adjacent side. 28 was our hypotenuse. So we're using cosine. You should get x is about 19.5. And number 12, x was an angle. 78 is the adjacent side. 25 is the opposite side. So we're using tangent. So we had to use the tangent inverse to solve for our missing angle. So x is about 17.8. With this trig stuff, we can also talk about an angle of elevation or an angle of depression. And when we talk about an angle of elevation, we think about looking up. So we have a dude, and the dude is looking straight forward. And if he looks up, the angle that is created is called the angle of elevation. So I like to picture him with lasers coming out his eyes. He looks straight forward, and then he looks up. The angle that he's creating is the angle of elevation. Angle of depression is when you're looking straight out, and then you look down. So that angle that's created is the angle of depression. What's important to note here is the angle of depression is congruent to the angle of elevation because they're alternate interior angles. Remember those alternate interior angles? Okay, so if I have an angle of depression, okay, so let's say it's a bird. Bird looking out and then it's looking down. There's my angle of depression. And let's say it's looking at, I don't know, a boat. Okay. The person on the boat was looking out and then looked up at the bird. So there's my angle of elevation. Well, these lines are parallel. Alternate interior angles are always congruent. So your angle of depression and your angle of elevation will be congruent. One of the biggest mistakes that students make here is kind of a silly mistake, but they label wrong. They will say that this is the angle of depression. No, that is not the angle of depression. The angle of depression is formed when you're looking out horizontally and then you look down, not the other way around. So be very careful with that. Most of the time, we're going to see angle of elevation and depression in word problems. So when you do that, it's a really good idea to draw a picture. And again, you don't have to be a good artist. Clearly, I'm not a good artist, and you'll see that in a moment. Okay. So Casey sights the top of an 84-foot lighthouse at an angle of elevation of 58 degrees. Okay, so here's Casey. Here's our lighthouse. I can't draw a lighthouse. This is my lighthouse. Okay, it says angle of elevation. So Casey looks straight out and then looks up. So here's my angle of elevation. It's 58 degrees. If Casey is 6 feet tall, how far is he standing from the base of the lighthouse? So the distance between him and the base of the lighthouse is here. Okay, so we have a right triangle. I guess I should have made my lighthouse maybe have a straight side. That's okay. So we have a right triangle here. This is 58 degrees. I don't know this length. And I'm missing, 84-foot tall lighthouse. Okay. Now I'm not going to put an 84 right here. This is not 84. Why not? Well, notice the line of sight was not exactly at the ground. Casey's eyes were not on his feet. Casey's eyes are 6 feet above the ground. So between here and here is 6. So this distance will be 84 minus 6, or 78. So we just have to watch out for that. Now that we have our right triangle, we can solve for x. 58 is our angle, 78 is our opposite, x is an adjacent. So we're looking at tangent. The tangent of our angle is the opposite over the adjacent. We will cross multiply here. Oh, we got to divide by the tangent of 58. That's okay. So those will cancel. So x equals 78 divided by the tangent of 58. So in our calculator, we'll type 78 divided by tangent 58. So 48.7. Our units are feet. And there's our answer. Okay, let's look at the last example here. A lifeguard is sitting on a platform. Okay, I am not, the greatest artist, but here's my lifeguard on a platform. Wearing a hat, okay. Looking down at a swimmer in the water. Here's our water. Here's my swimmer. Okay, so the lifeguard looks out horizontally and then looks down at the swimmer. So here is an angle of depression. If the lifeguard's line of sight is 8 feet above the ground, so from here to here is 8, and the angle of depression to the swimmer is 18 degrees, here's my angle of depression. How far away is the swimmer from the lifeguard? Okay, let's look for our right triangle. It is here. Okay. Now I know that this is 18, not this angle out here. Okay. I know that this height is 8. I'm looking for this length. So now how could I find this angle? Well, remember, alternate interior angles are congruent. So if the angle of depression is 18, so is the angle of elevation. So now I have an angle, an opposite, and an adjacent, everything I need to solve. The tangent of 18 is the opposite over the adjacent. Cross multiply. 8 equals x times the tangent of 18. Divide both sides by the tangent of 18. And in my calculator, I'll type 8 divided by the tangent of 18. So our answer is about 24.6 feet. Okay. So that was 4.4, practicing inverses. I do highly recommend doing the OMHS material. There are some good practice problems there. If you need additional practice or additional help, please make sure you're attending office hours or reaching out for some extra help. Today's attendance word is inverse. When calculating an acute angle in a right triangle, you should use the inverse of the trig function. Have a great day, everyone.